Good day. Welcome to the Engineering and Geosciences Annual Research Summit 2021. I am Christopher C. Sidaya, a fifth-year mining engineering student under the advisory of Miss Marie Claire over to DASA. To start, our research entitled Fuel Consumption Prediction of Dump Truck Using Artificial Neural Network and Support Vector Regression in Platinum Group Metals Corporation, a comparative study. These are the topics that I will discuss during my presentation. Introduction, objective of the study, methodology, result and discussion, and lastly, the conclusion. In surface mining operations, haul trucks use diesel as the source of energy. Haul trucks are generally used in combination with other equipment such as excavators, diggers, and loaders according to the production capacity and site layout. Haul trucks use a great amount of fuel in surface mining operation. Hence, mining industry is encouraged to conduct a number of research projects on the energy efficiency of haul trucks. This study will be conducted in Platinum Group Metals Corporation. This paper focuses on comparing the predictive capability of two models of fuel consumption prediction of mining dump trucks, and these are the artificial neural network and support vector regression to investigate the fuel consumption prediction models applicable to surface mines. The main objective of this study is to select fuel consumption prediction model of dump truck that could potentially be used to predict the amount of fuel consumed in Platinum Group Metals Corporation. Specifically, the study aims to compare the performance of support vector regression and artificial neural network in modeling the fuel consumption of large truck fleets using the available data to interpret and evaluate the level of accuracy of the two predictive models for the fuel consumption prediction. And these are our research methods or our methodology or our conceptual framework. First, we have the communication and consultation, determination of parameters affecting the haul truck fuel consumption, data gathering, data analysis, and comparison of two models used in predicting fuel consumption. After we gather our data, now we have our result. In this figure, it shows the actual and predicted fuel consumption of DT-174, who was 6x4. We have two tables shown, test evaluation and prediction. We have our root mean square error using SVR model, and we have the result 3.6500470421580746 or 3.65. And in prediction table, using the SVR model, we have the root mean square error 67.899638657056 or simply 67.90. And the original is 66.0. I will further discuss in that slide. Figure 1 shows the fuel consumption expressed in liters. The number of data represents the number of the actual record collected with its corresponding fuel consumption used. Values beyond orange colors. Colored bar represents the predicted fuel consumption based on the data that was fed in RBF support vector regression. It can be observed that the values predicted is not too far from the actual values of the data. As shown in the graphs, the hauling equipment uses the support vector regression shows nearly exact and accurate. As shown in the table, after the test evaluation was done, the root mean square error or the RMSE using SVR RBF is 3.65 as what I have said a while ago. And also, it shows in the table that the prediction of the specific hauling equipment was not too far but nearly accurate from the original fuel consumption. In this slide, it shows, and we're going to discuss the artificial neural network. In this figure shows that the actual and predicted fuel consumption of DT-174 using artificial neural network. We also have two tables here, the test evaluation and the prediction table. Figure 2 shows the fuel consumption expressed also in liters. The number of data represents the number of the record collected with its corresponding fuel consumption used. Values beyond orange colored bar, it also represents to the predicted fuel the values beyond orange colored bar is the actual, and the blue bars are the predicted ones. It can be observed that every prediction, the traverse value weights rather are not stable throughout the network or layers. So the value predicted is far and not fixed from the actual values of data. As shown in the graphs, the hauling equipment uses the artificial neural network is not accurate and far from the actual values. The hauling equipment DT-174 was chose to discuss further result of the data that was being performed, executed, and created by model artificial neural network. DT-174 datasets were being fed into the algorithm, then after it has been trained, as shown in the table, the root mean square error RMSE using artificial neural network is 4.387482. So, we are going to discuss the comparison of two model, which is the SVR and the ANN. In this slide, it shows two tables and the graph of two model which is being compared. This figure predicted fuel consumption of DT 174 Huo using SVR and the ANN model. The graph shows the output of combined fuel consumption prediction of artificial neural network and support vector regression models. The major contribution of this study has been to provide the best prediction method of the fuel consumption using the model's artificial neural network and support vector regression. The study investigated the fuel consumption prediction of hauling equipment. Two models developed and their performances being compared. Based on the study, the researchers concluded that the gathering of datasets has a great factor in the overall process in obtaining the best fuel consumption method required. This is for the reason that the data gathered was limited. The researchers further concluded that the best fuel consumption prediction method is the support vector regression. Based on the results in the models, support vector regression got the least root mean square error, which results to 3.65004704215800746, or simply 3.65. And that's all. Thank you.